In this video, I will be using dimensional analysis to determine whether or not a dose is safe. We are told a newborn weighing 6 pounds 2 ounces has an order for ampicillin 60 milligrams IV every 8 hours. The recommended dosage is 75 to 150 milligrams per kilogram per day, and we need to determine whether or not our order is appropriate. Notice, and in the general idea about these problems, what we want to be able to do is to compare the order with what's recommended. And depending on this information, the order and the recommended, we need to make a determination whether or not our order is safe. The problem is the order and the recommended as we see them now. The order is 60 milligrams every 8 hours. And what's recommended is 75 to 150 milligrams per kilogram per day. We cannot determine, as they stand right now, we cannot determine an answer to this problem. What we need to be able to do is to get the order and the recommended to have the same unit. 60 milligrams every 8 hours, this is the same thing as 60 milligrams per dose. Whereas the recommended is 75 milligrams per kilogram per day. So the general idea is if we were to, let's say, customize this recommended, we would need to eliminate the kilograms and turn this unit of day into a unit of dose. So we need to get these to match. The only way that we can eliminate this unit of kilograms is if we can multiply by the newborn's weight. And we are told that the newborn weighs 6 pounds 2 ounces. Immediately, I know I need to change that into a unit of kilograms. So what I have to do is first, and this is kind of a review, changing ounce into pounds. I must convert these 2 ounces into a measure of pounds. I know, if I'm starting with 2 ounces, I know there are 16 ounces in 1 pound. So those would cancel. I would have a unit of pounds here. This is going to be 0.125. This is telling me that this 2 ounces is equivalent to 0.125 pounds. The child already had 6 pounds that they weighed. So if I were to add 6 to this, the child's weight in pounds is 6.125 pounds. That's only step 1. Now that we know the total number of pounds, I need to convert this to kilograms. I know, once again using dimensional analysis, there are 2.2 pounds in 1 kilogram. So what I'm going to do now is to take this 6.125 and I'm going to divide this by 2.2 and I'm going to round my answer, so this is approximately, to the thousandths place. So I will get approximately 2.784 kilograms. That is the child's weight. Now that I have that information, I can take what's recommended over here, the 75 milligrams per kilogram per day. I'll start with that. So 75 milligrams per kilogram per day. And I can multiply by this child's weight of 2.784 kilograms. And what's going to happen there is I will eliminate this unit of kilograms. So if I take 75 and I multiply that by 2.784, I will get 208.8. And this unit would be milligrams per day. If I repeat this for 150 milligrams per kilogram per day, and by repeating, I mean multiplying by the patient's weight, that will eliminate this unit of kilograms, and I will be left with a unit of milligrams per day. So 150 times 2.784, I will get 417.6, and once again, the unit is milligrams per day. As we stand right now, this is what's recommended. We need our patient, if our patient has anywhere between 208.8 and 417.6 milligrams per day ordered, then it's appropriate. The issue is over here, I'm looking at 60. And I'm saying, wait a second, 60, that is not in between 208.8 and 417.6. We cannot actually answer this question right now. And the reason why is because our order, as it's written right now, 60, this is number of milligrams every dose. On the right side, we have the recommended as milligrams per day. So what I need to do is to take this 60 milligrams per dose, and I need to eliminate this unit of dose and convert that into a unit of day. And the only way to do that is to consider, if you were to follow through with this order, how many times would you repeat? And that information is given by this Q8H. This is telling us that we're going to have 3 doses in that one day. 24 hours, I'm breaking the 24 hours into 8 equal pieces. That means I'll have 3 doses. Now, if I multiply, notice if I multiply by 3, I will have 180. This will be milligrams per day. I am now at a stage where I can compare my order with what's recommended. I would say that this is not an appropriate dose for this patient. The reason why, it does not fall within the recommended range for this patient. So once again, I would state no, and my explanation is the order is not within the recommended range. In summary, I'd like to mention that there are a lot of ways to do these problems. If you look throughout this page here, you'll notice I have a lot of work and it's kind of scattered all over the place. If I were to redo this problem, what I would recommend doing is to think about, in all of these dose safety check problems, you need to be able to compare the order with the recommended. And the only way to do that is to get those units of the order and the recommended to match. In this problem, the order was given to us as a measure of milligrams per dose, and the recommended was given to us as a measure of milligrams per kilogram per day. Immediately, I knew that I would need to eliminate kilograms, and somehow, regardless of whether it's you're adjusting the recommended or the order, you also need to consider the number of doses. So in both of these situations, at least with regards to the weight was used to eliminate kilograms, and then the Q8H was used to consider how can I get the order and the recommended to match.